Dear students, in this video we are going to see exercise 4.3 question number 2. Solve the following homogeneous differential equation. So x minus y dy by dx is equal to x plus 3y. So clearly here we can't do variable separable method, and if I write dy by dx is equal to x plus 3y, this if it goes to the other side divides x minus y, clearly the numerator and denominator degree is of 1. So it comes under the homogeneous differential equation. Now in this case, since it was like dy by dx, put y is equal to vx. So for this, let's differentiate with respect to x. Y derivative is dy by dx is equal to, now here it was like uv. So what is uv formula? uv dash. So x derivative is 1. So v into 1 is v plus x into derivative of v. Derivative of v is nothing but dy by dx. Now let's substitute dy by dx whatever that you got here in equation 1 in place of dy by dx. So v plus x dy by dx is equal to x you write down as it is, plus 3 into y. Y is nothing but vx. Okay, so write down vx in y place. Similarly in denominator also in y place write down vx. Now clearly I can take x common in the numerator and x common in the denominator. So after taking x as common, cancel the x terms. Now here this v, whatever that you have, you take it to the other side, becomes minus v. Now let's take LCM on the right hand side. So 1 minus v is the LCM. So 1 minus v is the LCM, and so therefore 1 minus v multiplies to this minus v. So this is your numerator. So 3v minus v will become 2v plus v square. Now this is like in the form of a plus b whole square. V square plus 2v plus 1. 1 can be written as 1 square. So the numerator is fully in the form of 1 plus v whole square, or you can write down v plus 1 whole square also. And denominator write down as it is. Now clearly all these are the v terms. We can take it to the other side with respect to dv. And here x by dx. X by dx, if it goes to the other side, it becomes dx by x. So I have done here variable separable method. So after separating, here dv should come. Okay, dv, here also dv is missing. So after separating the terms with dv and terms with the dx, so we can integrate on both the sides. And if I do integration, clearly here you will get integral of 1 by x is nothing but log x. But here the integral term, it's very difficult to find. So that's the reason you have to do partial fractions. So let us consider this equation as 2. And consider only this particular term alone, and let's do partial fractions. So 1 minus v by 1 plus v the whole square. So split into partial fractions. Here we have done the partial fractions. Partial fractions. So you have to do the partial fractions and then only you will be able to simplify. So a by 1 term plus b by the repeated term, the whole square term. Now let's take LCM. So 1 plus b whole square is the LCM. So you will get a into 1 term of 1 plus v plus b. Now clearly your LCMs will get cancelled. So numerator 1 minus v is equal to a into 1 plus v plus b. So now let's put v is equal to minus 1 because I can eliminate a value. If I put v is equal to minus 1, b value you can find it as 2. Now put v is equal to 0. In v place if I put 0, you will get in terms of a and b. But anyway b value is 2. So if I take 2 to the other side, you will get minus 2. So minus 2 plus 1 is nothing but minus 1. So after finding a and b values, substitute in the partial fractions here. So this is what the partial fractions after separating, we got a value as minus 1 and b value as 2. So after finding the a, b values, now this is nothing but in equation 2 only, we have simplified and we did. Now let's substitute the whole term, these two terms in equation 2. So in place of this, write down 1 minus 1 by 1 plus v plus 2 by 1 plus v the whole square is equal to integral 1 by x dx. Next, so this is the term. Now here integral of 1 by v, this is like integral of 1 by x is nothing but log x. So log x, and this minus will be as it is. And since it is not exact v, so you have to differentiate. So anyway y derivative will become 1. 1 plus 0 is 1. So you have to write on divided by 1. But anyway since it is 1, it's if you don't write also, that's okay, fine. Now here what you have, 2 by v plus 1 the whole square. So integral of 2 is a constant, 1 by v plus 1 the whole square. So v plus 1 the whole square means how we can write this? You can take it to the numerator. So v plus 1 whole power minus 2 dv. Now this is in the formula of integral of x power n. So what is integral of x power n? X power n plus 1. N plus 1 by n plus 1. Okay, but clearly this is not exact v. So its derivative, what is its derivative? V derivative is 1, 1 plus 0, anyway 1 only. Okay, so here 2 into v plus 1 whole power minus 1 by minus 2. Minus 2 plus 1 will become minus 1. So you can write down very clearly as minus 2 by this v power minus 1, v plus 1 whole power minus 1 can written as, you can take it to the denominator whole power plus 1. So the same thing only I have taken. So instead of integrating all the same terms, you can separately you can do it. I have applied integral of x power n formula, and so therefore I got minus 2 by v plus 1. So after integrating I got minus 2 by v plus 1, and this is nothing but log x, and I have taken the constant as log c. Now this log term, negative term also, let's take it to the other side. Now here I can apply the product rule of logarithms, because all these three terms are positive. So log of first term into second term into third term. So all these three terms. Now v in the question, y is nothing but vx. So from this, what is v? V is nothing but y by x. So in place of v I have substituted y by x. In place of v, substitute y by x. And then here let's take LCM in the denominator. So x is the LCM. So y plus x you will get. And here also let's take LCM. Now clearly your x and x gets cancelled, and this x comes to the numerator as you do the reciprocal. So you will get minus 2x by x plus y is equal to log of y plus x or x plus y into c. Now we know this one, log x base a is equal to n. From this, what is x is equal to? Base power n. Okay, this is the formula. If it is in logarithmic term, we can convert into the exponential form like this. Similarly, here the base is nothing but e. So from this, x plus y whole into c can be written as e power the term. So e power the term. Now here c, take it to the other side, you will get 1 by c. Now in the book bag they are given like k, some constant k. So what they have considered as this 1 by c, the constant term, they have taken it as k. So final answer is x plus y is equal to k into e power minus 2x by x plus c. This is your final answer, where your k is nothing but this 1 by c. K is nothing but constant, so you can leave it even 1 by c. But since in the book back answer they have just represented with k, so your k is nothing but the constant, k is nothing but 1 by c. So this is your final answer. This is your final answer.